Sir, did you hear my voice?
Oh, of course, of course.
Yes, yes, thank you. Shall I start, sir, then?
Go ahead, please.
Okay, sir, thank you. Good evening to everybody. Today, we are going to have a very good discussion on the developments with optical character recognition for printed Bangla at the British Library. Today, we have with us a special speaker, Mr. Tom Derrick. He is a digital curator working at British Library, London. So on behalf of Director General, National Library, and on my own behalf, I wholeheartedly welcome Mr. Tom Derrick in this occasion. I wanted to introduce Tom today to the participants and our officials. Tom is a member of the 2 Century of Indian Print project that will digitize and make available rare Indian books held at the British Library, London. He is interested in the creation of data sets through exploring optical character recognition technologies and supporting researchers applying the digital research methods to its collection. Prior to this, he has experienced across editorial development, production, and in the field of marketing functions for an academic publishers of digital learning resources. So I welcome once again this occasion. I request our Director General and Joint Secretary, Ministry of Culture, Mr. P.L. Sahu, sir, to give a welcome address in this occasion. Thank you, sir.
Thank you, Gajalakshmi, for a nice introduction. Let me welcome Tom to this webinar, Developments with Optical Character Recognitions for Printed Bangla at the British Library. I hope Tom is here.
Yes, I'm here. Thank you.
Oh, great, Tom. Thank you so much for being with us today. Let me introduce myself also in this process. I'm only the Joint Secretary to Government of India in the Ministry of Culture. Ministry of Culture has some 5-6 libraries, central libraries, which we manage from the ministry. And the topmost library is the National Library of India, which is based in Kolkata. I stay in New Delhi. However, we do not have a DG at the moment in the library. Therefore, I have the additional responsibility to look after its administration. You can very well understand my knowledge of OCR and all those technical things that you'll be talking. I would be a listener today. What more to say, to have you with all of us from British Library to speak on such a topical issue. Now the steps to create steps taken to create data sets through exploring OCR technologies for Indian language, and today we are talking about Bangla language, is a very welcome. The National Library will benefit tremendously because we have huge stock of Bangla literature with us, and as I understand, we have 22 scheduled languages in the Constitution, but we have several hundreds of languages within India. It's in a very diverse country with languages, with many scripts. With Devanagari being the very dominant scripts, there are many such scripts through which these languages explore. Therefore, in India, the scope for this technology is humongous, and I think to have a webinar of this kind is actually engage not only library people, a lot of people from the archives, from various other institutions in India. There are academic libraries who can really benefit from the OCR technology. With this, I would like to thank you, Tom, for making it and for being with us. And thank everybody who are actually participating today for this interesting meeting. I hand over to Gajalakshmi to moderate this meeting. Thank you so much.
Thank you so much, sir, for your good welcome address. I request Dr. K.K. Kochukoshi, our officer on special duty, to address the gathering. Koshi, sir? Hello?
Yeah, I'm unmuted. Yeah, okay. Good evening,
Yeah.
good evening,
Yes.
everybody. Our respected Director General Sahuji, Mr. Tom Derrick, my colleagues and friends and participants. I am very glad to be here attending this webinar. I mean, I am also, as our Director General said, not too much expected in the OCR. So I'll be very happy to listen to Mr. Tom. See, we have been, British Library has been a good collection of South Asian books, printed books. And earlier, I think Albertine Gore has published some of the catalogs. I had the opportunity to meet her. Then Graham Shaw also, I had met him once or twice. He's an expert in the early printed materials of India. And he has also helped me also. Now, in the same group, we have Tom Derrick also, who is becoming an expert in Indian languages and who is trying to develop optical character recognition for printed Bangla. And this will be a very great advantage to the Indian languages. And I think it's a continuous process with the other languages also. And National Library, of course, we are already in a collaboration with the British Library on this matter. It's a very happy moment, and I welcome Tom Derrick once again on behalf of the National Library. I welcome our Director General also, and I'm eagerly waiting for his lecture. Thank you.
Thank you so much, sir. Now the session is going to start. I hand over the session to Mr. Derrick. Let him start.
Okay, thank you very much. Can you hear me?
Yeah, we can hear you, please.
Excellent. Then I'll begin. Firstly, I'd like to say thank you very much for those kind words, those kind introductory words to introduce this session and to introduce me as the speaker. It's a pleasure to be invited to speak to you all today about the developments with optical character recognition for Bangla at the British Library that we've been working on. And special thanks to Partha and Guja for setting up this talk and giving me this platform to discuss the work that we've been undertaking at the library, which I hope you will find a useful session. It was interesting to hear that, of course, there will be many people on this call, I would imagine, who may have had limited exposure to optical character recognition. And therefore, I'm positioning the first part of this talk as more of an introduction to the topic of optical character recognition and OCR before I move into maybe some of the more technical aspects of what we've been working on. But I will also discuss not only what optical character recognition is, but why I feel it's important for our sector, for cultural heritage institutions, and the possibilities that it brings forward in terms of opening up access to collections on a much wider scale to your users of the library. I'll discuss some of the challenges that we faced and some of the tools that we have used specifically for printed Bangla, the results that we've had, and where we currently are with optical character recognition. So I was planning to talk for about 40 minutes, and I understand that after that we will probably have some time for questions. So with that in mind, I'll get started with my talk. Just I've been introduced already. Just to add to that, my role specifically is a digital curator on the 2 Centuries of Indian Print project at the library, which is a project that has been underway for several years now, since 2015. And we're making available printed books from the British Library's South Asian Printed Books collection, specifically Bangla books, Assamese, Sylheti, and some Urdu also. And the wider plan for that project is to continue long-term digitizing more of the British Library South Asian Printed Books collection. But through that, there has been a digital research strand for which I've been investigating the possibilities around optical character recognition. We try to extract the text and make it widely available for our users. Firstly, let's see if I can skip to the next slide. Yeah, for those of you who perhaps are unfamiliar with the British Library, it is the National Library of the United Kingdom and the world's largest library by number of items catalogue. The British Library was founded by an Act of Parliament in 1972, and the collections themselves were subsumed from the British Museum's holdings in 1973. So they came to the British Library from the British Museum. As a national library, we have a copy of every book, every magazine, every journal, and every newspaper published in the United Kingdom, as well as all born digital items. We have around about 180 million items, although that's kind of a rough figure and nobody can be exactly sure how many, but a huge amount of material that includes artifacts from every age of civilization, ranging from 3,000-year-old Chinese oracle bones through to Anglo-Saxon manuscripts, historical archives, audio-visual material, all kinds of material. And we actually receive 3 million new items into the collection each year. There are 2 main physical sites to the British Library. One is in London, and that's where the main British Library building is based, and which houses most of the collections. And then up in Yorkshire in the north of England, we have another site called Boston Spa, which holds the National Newspaper Collection. As you can imagine, with this vast amount of material, there's an awful lot to digitize. So far, we've only digitized 2% of our entire holdings. Therefore, you can think of digitization as a long-term effort. And most of the items still therefore need to be consulted physically in person by people visiting our reading rooms. So yes, we've digitized around about 2% of the collection, but the number and scale of digitization programs and projects that we have on is growing rapidly, especially with non-Latin language collections. And we do see that digitization is integral to the core mission of the British Library, which is to make its intellectual heritage accessible to everyone for research, inspiration, and enjoyment. So that's a bit about the library itself. Moving on to the topic for today, which is optical character recognition. Just to introduce OCR, what is it and what is HTR as well? Well, OCR is optical character recognition, and that is the conversion of images that contain text into machine readable text, so that machine readable text is compatible with computers. It produces text that can be processed, it can be searched, edited, analyzed, and integrated with other computer technologies. The way in which we create the text that is compatible with computers is through scanning an image of the page that contains text. And within the British Library and within other institutions within our sector, that process is undertaken largely through using scanning equipment. But it can also be done through a mobile phone, any device that can photograph a page with text on and capture that image can then be converted into text that can be read by the computer. Often the scanning is actually integrated into scanning software as well. There are two types of text recognition. One is for printed text, which is OCR, that we are more familiar with perhaps and has been around for longer. And then there is something called HTR, or handwritten text recognition, which is far more recent technology, but one that is making very good progress in terms of its efficiency at recognizing manuscript text. OCR for printed text is easier for the technology to read the text than HTR. So the accuracy for printed text recognition is much higher than it is for handwritten text recognition at the moment. This is because printed fonts are easier to read by the computer. They're more structured, whereas handwriting has a lot more variety to it. So it's often said that no two people have the same handwriting, and text recognition software likes images containing text that is consistent. So handwritten manuscripts with all of their variant styles present more of a challenge for text recognition. This isn't essential knowledge for OCR, but I thought I would include it in case anybody is interested in the background of OCR technology. It's been around for probably a lot longer than you might think. Certainly when I researched it, this 1912 date is earlier than I had expected. So the first images were trained with just one character at a time. The technology wasn't able to read, entire sentences. The technology had to be trained on individual characters. A lot of the early use of text recognition was being used to pass over text to help for people who were visually impaired or blind. So there were devices that were created that were able to pass over the text and produce a certain tonal noise for each character. If anybody has their microphone off, if they could mute themselves, that would be useful. Thank you. Yeah, so this was the main use for text recognition up until really the 1970s is where it really took off again, and OmniFont OCR could read virtually any font. So that was a big development. Then since the 2000s, we've moved into the era of cloud computing, real-time mobile applications, translation services, and again, the technology has reached a new level. And recent breakthroughs with machine learning are now delivering high-quality recognition results using something called neural networks. And neural networks essentially mimic the way the human brain reads and processes information. And that's now taken the technology up another level as well. There are now plenty of tools today that are available to perform text recognition, and they range from commercial offerings such as Abby Fine Reader, which can be thought of as a kind of market leader in this area and is often the technology of choice for many institutions. There's Google as well. They offer, as many people will be familiar, a service, and they have translation services and many spin-off technologies that essentially work with a similar technology to text recognition. Transcribers I put there, which sits in the middle, and I will talk a bit more about this service. It's one that we've actually decided to use at the British Library. It sits somewhere between commercial and open source, so it's free up until a point, but they've introduced a new pricing model for using that service, which is based on the number of images that you want to process as an institution and the size of your institution as well. Open source, some of the better known text recognition softwares are Tesseract OCR and Kraken. What can be recognized with OCR? Pretty much anything, any image that contains text should be possible to extract that text somehow, whether it is a stop sign, a car license number plate on a car. There's specific systems set up to read those, captures online as well, and in a receipt. So you can see there how it's marked up, and the structural format of the text as well has been captured. And bottom right hand corner, what we're interested in more so in the British Library and perhaps in your institution as well is material from our archival collections, both printed and handwritten. In terms of how optical character recognition works, this is a bit more of a technical slide, but hopefully I can explain it in a way that it's understandable to everybody. Begins with scanning. So the British Library, for example, we have quite two scanning operation teams, but both our sites and most of the projects that require text recognition, when they are digitized by this team, they also perform optical character recognition on the documents. We use a product called ABI. We have ABI Recognition Server, which is a proprietary commercial offering, and that is what we're currently using for most of our optical character recognition work. So the next stage after scanning documents is the pre-processing. So pre-processing can be thought of a way as of optimizing images before they are actually read for the text recognition. And the pre-processing helps mitigate any issues that an image might have to ensure that it gives the best opportunity for the text output to be as accurate as possible. Again, if people could mute themselves, that would be useful.
I request all the participants to please mute your audio and video, please. Somebody, caller 11 is coming. The name is not coming. Your video, your audio is on. Please mute.
Okay, I'll pick off where I left off, which was pre-processing. So one aspect of pre-processing, which most OCR systems use, is something called binarization. This is the process of turning color images or color scans of images into black and white. And by turning it into a black and white, or what we might call bitonal image, it more clearly distinguishes text on the page from the background. So that helps an OCR system which is looking for where there is text and where there is not text, and it helps it more clearly define the textual characters on the page. So there's binarization. There's something called noise reduction, which can otherwise be thought of as despeckling, and that's a tool that's often built into OCR systems which can remove background interference. So you might have an image that contains that is a bit aged and contains some marks or signs of age, but these tools can actually reduce the impact of that as it shows in the image. And again, if you had an image that contains a lot of background interference, an OCR system might accidentally and erroneously read that as textual characters, when in fact that's just background interference. So by being able to remove that, again, it just helps to leave only the text on the page for the OCR system to recognize. Skew correction, so often we have pages or scans of pages where the text is not perfectly horizontal on the page, and a lot of OCR systems have an automated correction system which helps the software, and the software is looking really for the most horizontal line to read across. So that is another tool which we use to help text recognition software to recognize the image. So this is an example of a noisy image, and you can see there is some kind of ink transfer there and blottiness on the back of the page, and we don't want the system to read that. So there is a tool that can be used to actually remove that without removing the text on the page, and an example there of a skewed image that can be corrected. So the next phase after this pre-processing is actually the page layout and analysis. So it's really important to try to read a page of text. Let's imagine we have a page with 2 columns of text. We want the text output from the OCR software to be able to produce a result that represents the original layout of the page. So we want the first column displayed correctly and the second column displayed separately. And this helps to preserve the reading order of the text, which has an impact further down the line on practitioners of digital humanities, digital research who want to and need to be able to read through the results of the text and extract the run of text as it appeared in the original image. So the way that the software works is that it will take the input image, the scanned image of text, and read it down line by line and segment that. So it's looking for a gap between the lines, a gap between pixels, and then it can identify and say, oh yes, so here is a gap between where the previous line was and this next one, so I know that this should be segmented into separate lines. So a lot of modern cutting edge technology for OCR is able to read the text at this point. Once it's been segmented into lines, it can read the whole line of text without having to segment further down into individual words. But the older OCR methods would still segment by word and down to character level recognition. And at character level recognition, just introducing 2 more technical terms here, there is something known as feature extraction or pattern recognition. Pattern recognition is a more basic approach to character recognition, and it's where the OCR software will identify the character on the page and it will match it to a database of known characters and then return the correct output in the result. Whereas feature extraction, and here we have a Bangla character, is a method which is a bit more clever than pattern recognition. It will break the character apart into its component features, and those features get mapped against a database again of shapes, and they can be again used to return the exact result. This method is better because it helps deal with more variability in characters on the page. So pattern recognition is just the shape of the whole character, but this method of feature extraction is better at being able to recognize where the same character has been written in a slightly different way, that's all. Contextual verification is the last step of the OCR software process. And it is once the OCR has been produced, the software has some inbuilt mechanisms to verify the results. So often they have some inbuilt dictionaries, which they can refer uncertain results to, and they can also give a kind of confidence score of how accurate they think the results are, and that's quite useful to us as users. And then there's various kind of post-processing tools outside of the software, and some of them are open source, which we can use to help correct results to bring them up to a good, accurate level. The sort of formats that can be produced from optical character recognition really do vary. So it really depends on what output you want. A lot of institutions in our sector will make images available as searchable PDFs, which is very useful because it shows you the original image, but it becomes searchable as well. So you can see in the top right-hand corner, I've searched for the word throne in this English language document, and it finds the word on the page and highlights it. And the way that the technology works behind that is behind this layer of the PDF is the XML. And this is a very scary and technical looking format. But essentially what this is showing us is the location of the words on the page, and it's giving us the vertical and horizontal pixel position of each word and each character on the page, so that when we do perform a search of a document, it knows exactly where that word is and it will highlight it on the page for us. So yeah, that's the format, but when thinking about which format to produce with OCR, we do have to consider what our purpose is, who we are expecting to use this ultimately. Perhaps the most user-friendly version is the searchable PDF, but you can also export results in a plain text format, for example. The XML that we have here, this is a format that is required by the British Library if we want to make our images and documents searchable through our image presentation platform. So we have something called a IIIF image viewer, and it's a place where I'll show it in a later slide. Users of our website can search the full text of our images, but our systems require this XML format, and specifically in a schema called Auto XML. Okay, so getting on to why is OCR and HTR important for cultural heritage? Well, it's retrieving information quickly is certainly one of the main benefits for OCR. So here we can see an image of one of our Bangla books within the image viewer that I was just describing. And when this is full text searchable, there would be a keyword search option whereby a user can search across all of the pages in this document, and their search will direct them to the page where their search term appears. So that, as you can imagine, is very useful to people. It brings them to information far more quickly than it would if they had to read the book manually. So full text search and discovery is one of the key benefits of this technology. Another one would be unlocking content for large-scale analysis. And this sits more with digital researchers and those that work within what we call the digital humanities field. So those are people who are often humanists, academics, who are trying to use technology to help them analyze large data sets for their research questions. So, for example, natural language processing is an aspect of the digital humanities and is used for text mining documents. So it's important when we are OCRing our documents that we're not just making them available online as images, but also as data sets from the raw files of the OCR. So these digital humanists, they want to be able to use all of the text files or the XML files. And it's important, like I said earlier, that the text recognition doesn't just recognize the text accurately, but also the layout of the text on the page. That means that, let's say we had some documents that contained street addresses. Ultimately, they could be extracted from the text and geocoded and used as a data visualization and plotted on an interactive map, for example. So yeah, again, this is not possible through just close reading. So how do we measure success? It's something called the character error rate or the word error rate. OCR is not perfect technology yet. For English language items, often it's quite close to perfect. With some systems, it can achieve 99% character accuracy or above. For non-Latin languages and Indian scripts, it's quite challenging actually. So the word error rate is always going to be higher than the character error rate. So you might have just one character that is incorrect, but that one character can appear in many different words on a page, specifically if it's a vowel in English, for example. So that means that every word that contains that character that is then therefore misspelled is considered an error, and that's why the word error rate's higher than character error rate. I like this quote, which reads as, usually the quality of the OCR text says more about the condition of the original materials than it does about the performance of the OCR software. And I think this is an old quote from 2008, but I think it still holds true that the greater impact on the OCR performance is more likely to be the quality of the original materials than the OCR software itself. And usually the way of finding that out is to use the same set of materials and put them through 2 different or 3 different OCR softwares to compare the results. That's the one way of discovering which OCR software is better. But what we found in our experience is usually the condition of the material is the primary reason that's going to affect the results. And if it's not in good condition, it's blurred, or the text is quite faint on the page, that's really going to impact the quality of the results. And I mentioned that English is easier for systems to read than non-Latin scripts. Yeah, if you have an old manuscript that is not in good condition, then that's going to require a lot more work to try to get good results from. Generally speaking, from what I've read, if we're looking at below 85% word accuracy, then that's not really considered very good results for OCR and not very useful for end users who want to retrieve all of the pages that contain their keywords. Getting on to the specific challenge of script with OCR, non-Latin scripts not widely supported by leading providers. The Indian scripts are specifically not supported by ABI, who I mentioned before are kind of the leaders in this field. I have asked them about this recently, and it seems like it's not on their roadmap to include anytime soon. So that's unfortunate, and it means that we have to turn to alternatives for Indian languages. Another reason why Indian languages, for example, and scripts can be more challenging than the Latin scripts are that they contain often extensive alphabets with what are essentially more complex character forms than English, varied historical, and then with archival material, library collections, we're all familiar with older material and varied historical fonts, alphabetical reforms. These all contribute to the complexity for OCR systems that trying to recognize archival type collections. A lot of OCR systems are trained on modern alphabets, modern dictionaries, and therefore if we're working with older material, they simply haven't been trained to recognize that a lot of the time. So usually we see that the more modern the material, the better results. There are different ways to overcome text recognition challenges, and you might be interested in some of these. Certainly one available resource is the Impact Center of Competence. So this is an initiative that has been set up to improve accessibility of historical printed text and is innovating in OCR technologies. Their website presents free tools for pre-processing, for post-OCR correction and evaluation of OCR results. There's a project out of Germany, which is a collaboration between several German institutions, which again is doing really good work around trying to set up a kind of best practice workflow for OCR tools and projects, specifically around, they're trying to develop the whole area of layout analysis and trying to improve that. One thing which I'll just move on to in a moment is creating something called ground truth, which are known as perfect transcriptions of a document. This has to be done manually, but it's very useful to create ground truth to then train OCR systems. And that's something that we've done at the British Library. And we ran a competition as well as part of the ICDAR conference. ICDAR is the International Conference of Document Analysis and Recognition. It takes place every 2 years. And I would recommend it if you are interested in if you have a collection, for example, that you want OCR created for, you can take part in this competition, and it invites people from across the world, specialists in OCR technology, to use their tools on your material. And at the end of the competition, a report is written, an analysis takes place, and you can get an idea of what systems out there are available for your material and give you a better indication of if you want to move forward with any of those partners in the future. So I've got a slide after this, I think, on that to talk to you about what we've done with the OCR competition. And then, yeah, I think it's important to make any ground truth transcriptions you do create available as openly licensed data sets that specialists can download and use to train their systems. And that can lead to interesting partnerships and collaborations. There are various crowdsourcing efforts that take place as well. So you can consider crowdsourcing your OCR creation, your ground truth creation. Projects that have done that include the three mentioned here: Transcribe Bentham, Transcribers web platform, and the British Library's In the Spotlight project. I've already explained a little bit about 2 Centuries of Indian Print project, so I'll skip over this quite quickly. But our specific need was to both digitize and try to extract the text from a range of South Asian printed books, predominantly Bengali books, but also Assamese and Sylheti. And these are mainly books from between 1713 and 1914 that cover a range of interesting, diverse topics. And as well as the books, we had some catalogues of printed books in India that were digitized at the British by the British Library. So the initiatives that we've undertaken with this specific 2 Centuries of Indian Print collection are the ICDAR conference, both in 2017 and 2019. We partnered with a very interesting laboratory called the Prima Research Lab out of the University of Salford in England, and they are experts in OCR analysis. So this is just an image here of one of our pages from the Bangla books. And you can see how we have marked up different elements on the page where there is a paragraph of text, where there is an image. We had to draw around these features on the page and label them appropriately. And then just to the right, you can see that that shows the transcription, the transcribed text as well. So for this competition, over the 2 competitions, we've had 23 institutions take part from 8 different countries, half of which were from India. And we had entries from computer science departments, private industry as well entered, Google, Microsoft, others. Yeah. And the process that we used, and again, I would recommend this ICDAR OCR competition approach if you do have a collection. You firstly need to select images from the collection that you want OCR for. You want to be able to select a representative range of materials, so different layout styles of pages where the font and the typography changes within collections to really get together a comprehensive data set that fairly represents the collection. And then you have to create the ground truth training set, which involves drawing around the textual and visual elements on the page, labeling them, and transcribing them as well. So we were very much helped out by Jadavpur University, who provided the textual transcriptions for us for our Bangla books. We then gave all of this information to the entrants of the competition, and they used that to train their ground truth systems. They perform OCR. We then gave them more images from our collection. So we gave them images which we hadn't transcribed. We just gave them the raw TIFF image files. And they, after they had trained their systems, they put through these images and got some results, which they sent back to us and to the Prima Research Lab, who evaluated them. yeah, that was eventually written up and published as part of the conference proceedings. In terms of the actual results we've had, you can see here on the left of the 2017 results and 2019 results on the right for comparison. The character accuracy, this is the text character accuracy. So Google were the most successful method in 2017 and again in 2019 actually. Their method is 75% accuracy. And you only need to pay attention to the red bar, not the blue bar on this one. Tesseract is the open source system that I mentioned to you as well. So perhaps where budget is an issue, Tesseract is certainly a tool that I would recommend you consider. You can see the accuracy for Bangla is quite low there, 54% accuracy. But it improved slightly when we used the binarization method from Abby software. So again, without wanting to go into too much technical detail, it highlights the importance of the pre-processing aspect of OCR. So that binarization process of turning an image from black to white is quite important, and it can lead to better results in the accuracy ultimately. So Google, 2 years later, we ran the competition again, and Google's method again achieved a very similar result of 75%. Tesseract actually decreased in its performance, and that might be because we introduced more images for it to be evaluated on. And as we introduce more images, we probably introduce more complexity and variance for the system. Yeah, they didn't get results. So competition. So as well as text accuracy, the page segmentation was very important. So the way this was evaluated was that we had drawn a bounding box around each of the textual paragraphs on the page. And as competition entrants produced their results, there was a sort of geometric analysis and overlap between their results and the ground truth transcriptions to see how closely the elements matched on the page. So Google did very well, and ABCD, which was a method out of Jadavpur University, is also quite successful in terms of preserving a page layout. Yeah, and even Tesseract improved quite substantially. So anyway, moving from the competition, we didn't really get very good results ultimately. We didn't feel that the accuracy we were getting was good enough for our project to say, yes, let's use this tool for all of our books. So we decided to look again, and we tried a different tool called Transcribers. Now, Transcribers is, as I mentioned at the very beginning of this talk, something that you can download currently for free, and you can use on a limited number of pages for free. But increasingly, they're asking institutions to sign up to their cooperative system, whereby you pay a fee for, like a one-time fee for perpetual usage of Transcribers. So it's a research platform for digitization, transcription, recognition of and searching of historical projects. It started in 2020 as part of the READ project, and sorry, it started in 2016 as part of the Horizon 2020 READ project, and it's out of the University of Innsbruck in Austria. The British Library signed an MOU in March 2017 after we had a successful trial of using it for our English language India office collections. And yes, recently they've transformed themselves, and we are now one of the founding members of their new mode of working, which is as a SC, European Cooperative Society. So what can transcribers be used for? It's automated recognition for handwritten and printed text. It requires, so this is the big thing with it, it requires at least 100 pages of ground truth transcriptions, which have to be created manually. So you have a page of text, you have to transcribe manually the whole page of text. And you would need to do that for at least 100 pages to train the Transcribers neural net engine to then be able to automate the recognition of the rest of your material. Now, you need to, if it's manuscript material, you'll need to create more than 100 pages, a lot more than that. With the printed Bengali, we have worked off about 150 pages, I believe. But the good thing about Transcribers is it can be trained to recognize any Unicode script. So it's particularly good for non-Latin manuscripts or non-Latin scripts, for the Indian scripts. And you create something called models. So once you have transcribed it and you train it, which is very easy to do actually for complete novices like me as well, and it doesn't require a lot of technical background. It's quite an easy, intuitive system to use. You can share language models as well. So if you do decide to use this, it's worth looking at whether there are other Indian languages that have already been trained using this system. And if you're interested in that, then do get in touch with me after this and perhaps help with that. I do know that the University of Heidelberg have been using it for Hindi, I believe. And we are making our Bengali model available as well, openly. So you can integrate external transcriptions as well. So if you already have transcriptions of documents available, you could integrate them with Transcribers, and that helps towards the training of the tool. The other features include keyword spotting, which is a way to search the full text of your documents within Transcribers. And they have something called a scan tent, which is a piece of equipment that you can purchase. I believe the cost is about 250 euros. And for that, you get a small tent, and it has an opening at the top where you can place your mobile phone or smartphone. And it includes an app as well. So you can kind of set it to capture books or documents that you place within the tent, and it will automatically capture each page as you turn the page. It's quite a good initiative for archives or libraries that don't have scanning equipment already, and it's mobile equipment as well, so you can move this small tent from room to room. Might be of interest. Just to quickly go over, I realize I've gone over my 40 minutes, but hopefully we have time. I probably need another 10 minutes if that's okay. The Bengali workflow for Transcribers involved us again selecting images from our Bangla books, representative sample of them. Jadavpur University were enormously helpful in transcribing 154 pages of those. And we also had to draw the structural elements on the page like I'd shown you before, where there is a bounding box around the text or the image. And we combined the transcriptions with the structural drawings within Transcribers, and we then created a trained model and reran it with more transcriptions. So the good thing is you can continue adding more and more transcriptions of ground truth to Transcribers and keep training it, and each time, in theory, it should improve in terms of the accuracy of the results. So it has some inbuilt mechanism and tool for actually computing the accuracy of your results as well, which is quite useful. And now we've actually begun just automating the recognition of our Bangla books by all we have to do is upload them to Transcribers, press a couple of buttons, and it automatically generates the text recognition for those books. But the hard work was actually a combination of ourselves and Jadavpur University creating the ground truth transcriptions. That's where the work goes in. In terms of the results that we are getting with Bengali, the HTR Transcribers engine achieved 5.23% character error rate. So they are, just over 94% accuracy, which is very good indeed. We didn't get that the first time round. You can see from the table colored in yellow to the right there that we have trained 3 different models. The first after just transcribing 51 images, and the last one after 148 images. And there was quite an improvement in our accuracy. So it gives you an idea of what hopefully is required And this is printed material in very good conditions, so it's a lot easier for this transcriber system to deal with than manuscript items. And if you had older manuscript items, you would probably need to create a few hundred, 300 or 400 pages of transcriptions first of all to get these kind of results that we're getting. The graph on the left just shows the learning curve of the software as it produces the results. So now that we have pretty good results for Bangla using Transcribers, what are our plans now? Well, we are producing results automatically, like I told you, and one idea is for us to manually correct the results that we're getting, which will be quicker than us actually having to fully write out the whole, all of the text for a particular page. So if we upload a page, automatically recognize it, it's going to be probably, let's say, 90 to 95% accurate. If we can correct that to ensure that it's 100% accurate, then we can use that 100% accurate transcription to train transcribers again to keep improving. So it's a continuous cycle of improvement that we can think of. Use models to automate OCR for all 2 centuries of Indian print Bengali books. Yeah, so this is introducing some jargon from the British Library here. DAMPS is our digital asset management software. It's our repository. Hello?
Is any network issue, Tom?
Can you hear me?
Yeah, we hearing your voice.
I'm very sorry. Yes. It seemed like the connection dropped. I'm not sure at what point you lost me there, but I'll just pick up from this slide, I think, because I realize that I'm going over time. Yes, just to cut to the chase then, the main benefits and challenges of Transcribers are that it's very easy to use. You can manage an entire workflow from uploading images to creating the ground truth, to running the text recognition and exporting the results in the format that you require. You can do all of that yourself, and it's very easy to learn how to do it. They have a quite comprehensive guidance on how to use it. So it works as well. So we found, and we know that other libraries, from attending the Transcribers conference, we've heard many talks from libraries of them saying how successful Transcribers has been for them. And it's quite possibly the best option for handwritten text documents. But as I say, we've used it for printed Bangla and it's worked very well. You can share models, which saves work. Some of the challenges are the investment of time. So you have to, as I've said, create a lot of manual transcriptions. But it depends on the resource availability. Perhaps it's not too difficult for you to create a couple of hundred transcriptions. That's what it requires. And then some more technical elements here about baseline. So you can automate the drawing of lines under each line on a page. You just have to be careful about that working when you're importing external transcriptions. And there's different practices when you're using it about version control you have to be aware of. But yeah, it enables you to label your work when you finished it and mark it as complete, and then you can that helps you manage the whole system. Yes, the integration with the image viewers at the British Library. This is a closer look at the what we call the IIIF compliant image viewer. It's keyword searchable. You can, if other libraries are using the same technology, it's possible to pull in images from their digitized collections and view them side by side against the digital collections that you have. You can download pages as JPEGs or PDFs as well. It includes citation, export, and license terms as well. So that's what we are working towards with the Bangla books at the moment. We're actually testing whether the full text search works within our system of the Bangla books at the moment from the OCR that we've produced. But then moving on to the last few slides. So another use of OCR isn't just to make something full text searchable. It's, as I said, for digital humanities to be able to extract information from OCR text and use it creatively and or in interesting ways. Something we did was OCR a catalog that contained metadata of books published in India in the 19th century. And these catalogs contained information about the location of printers and publishers, of course, the name of the book, the author, the date it was published, etc. It also included the street address of the printer, which we found interesting. So after we OCR'd this and exported it, we were able to, we had to do some manual cleaning of the data in Excel. But yeah, we got the information OCR'd in quite a structural format. So we were able to upload the OCR that we had in Excel format to a platform called Tableau Public. And Tableau can be used for data visualization. We used it to create a map showing the location of book printers in Calcutta in specifically the year 1867 to 68. So this final view that you can see here was only possible because of OCR. It includes a few thousand records of books, and we were able to aggregate the data. So for each printer, we can see how many books that they printed in that year. We were able to detect from the catalogs how much the books were sold for. And we've even linked from this map into the catalog, the British Library catalog, so one can follow through all the way to the digitized book itself with that's available through our catalog. So yeah, it was quite a nice use of OCR. We've made the data sets that we've produced from optical character recognition available through the British Library's research repository, which is an open source repository. You're very welcome to go to this address, which is bl.iro.bl.uk. And within this, you'll find lots of digitized images and derived data sets from digitized British Library collections, which include the 2 centuries of Indian print Bangla books. We've made available the OCR results from that. So again, if you actually know anybody or you yourself are working with OCR systems, you're very welcome to find this, download it, and use the training transcriptions that we've created for your own system. And then just another initiative, another way of trying to engage our sector with OCR has been the workshops that we've conducted in India. So that you can see photos of Jadavpur University and the Asiatic Society of Mumbai. So these are where we were running some practical sessions around the use of optical character recognition. We were introducing some of the tools that I've talked about today, Transcribers, Tesseract, and people who attended these sessions were able to use those and practice with them. So it turned out that they found that the most interesting part of the workshop itself, this practical activity. So that's something that we think we will continue with if we are able to run future workshops in India and South Asia more generally. So yeah, we're very interested in hearing from you if you have been using OCR, in what ways you have been using it, difficulties you've faced, and what your plans are for using it as well. So these workshops have been quite useful forum for talking about that. Oh yes, and we've also made some training material available through our project website, Early Indian Printed Books. So if you can access this website by, perhaps the easiest way is to search Early Indian Printed Books in Google. You go to the Training and Resources tab at the top, and there's a guide for how to use Tesseract open source, because it's a little bit tricky using Tesseract, requires command line usage, but there is a guide which will help get you started if that's of interest to you. And yes, that brings me to the end of my talk actually. So should we start with some questions?
Yes, thank you, Tom, for your very much informative session. We really enlightening with the many information about the developments of printed Bangla OCR. So I open the discussion among the participants. I request the participants, if you have any questions, you please raise.
Tom, I have a question. So you were telling that transcribers is only for Hindi and Bengali, you have found. But is there any possibility of using the transcribers in other Indian languages? What is your opinion?
Yes, absolutely. Sorry, I didn't explain that fully at the time, but transcribers can be used for pretty much every language. However, the key thing that you need to do is to manually train it first. So hopefully I made that clear when I was talking, that you have to create manual transcriptions. I've discovered in the past some people have misunderstood, and they think that they can just upload the images to transcribers and click a button and for it to work straight away. But if you have some material in whatever Indian language it is, it's definitely possible for you to be able to have that recognized by transcribers. But first of all, you will probably need to manually transcribe some of those pages, at the very least 100 pages, I would think. Then you train transcribers, which is easy to do. And after you've trained it, then you can start uploading more and more images, and then you can just click automate. You can press a few buttons. Does that make sense, what I've said? Yeah.
What is the success rate actually? Can you tell us that what is the success rate we can achieve?
Yeah, it's very high for printed Bangla, we found.
Yeah.
So 19th century printed Bangla from our books, it's about 94% character accuracy, which is definitely good enough for us to use, for us to say, yes, let's use this, let's automate at this level of accuracy. And it can be used then for other systems, so we can use that for the full text searching online of our books. It's going to ensure that people who are searching our books are going to find most cases of the words they're searching for. And it's good for those digital humanities practitioners as well, who require accurate information, because they don't want to base their research on a data set that's full of errors. So we have to give them confidence that the OCR accuracy is high. So yeah, transcribers is the best that we have had. It's the best result. You know, Tesseract open source, they're improving it all of the time. They're always releasing new versions. They have a team, they have developers who are always working on that. So that's something that you can also download for free and try. It's worth just trying, and I'd be happy to put you in YouTube different guidance. Yeah.
Hello, I am Prithu from Jadavpur University. I am a student of English literature, and my mother tongue is Bengali. So I have keen interest in the OCR for a while right now. So I want to ask whether it is necessary to have a knowledge on algorithms to work on OCR. and how can a student of English literature can contribute upon the development of OCR?
Yeah, thank you, Preeti. That's a good question, and I can say that you don't need to know how the algorithms work. It's that was a relief for me as well, because actually I was a philosophy graduate, which not computer science. And what the most useful thing to know, I think, from your point of view is firstly what you are trying to create. Like what is your end goal? Are you trying to create results that are going to be used for display online, or are they going to be used for researchers who require digital humanities skills? You want to have an idea of what is acceptable to you as results, I think. But in terms of actually using the software itself, you don't need to know all of the technical elements that I talked about today. That was just, I introduced some of those out of interest rather than need to know. If you're using Transcribers, for example, it's very simple to use. They have a lot of guidance. You don't need to write algorithms at all. It's important for you to know your collection. That's really important. You have to know the condition of it, what the different layout styles are, the different typographies, if you know that. You need to try and have an understanding of how your collection is represented. And to train these systems, best of all, you'll have to try to create manual transcriptions from a representative sample of that collection. But yeah, certainly don't be concerned about having to know the algorithms. That's not essential at all.
Tom, this is Bahu. Thank you so much for, in fact, the pandemic has brought us together for such an interesting subject. Very, very, topical to the libraries and the library developments in India. I just, the OCR for English and other European languages, as you say, has been able to achieve a very high percentage of accuracy for, in conversion. But the OCR for Indian languages were not able to achieve the accuracy they're supposed to achieve. This is mostly or probably due to complexity of Indian languages, or the lack of standard representation or encoding support of operating systems or keyboard and many, many other factors. Now, India's linguistic diversity shows many forms, oral traditions, even it is prevalent now, and the literature, films, and of course the scripts, various scripts that we use. However, diversity comes with its own challenges, isn't it? And just wanted to check with you: is it possible to use an intermediary language or script, between languages, similar to something Latin used by the European languages?
Yeah. So I agree with what you were saying as to what the challenges are. And I think the biggest challenge of all, the biggest reason perhaps why the Indian scripts and other scripts don't have the same accuracy is that a lot of the providers for OCR technology, particularly the commercial providers, began by training their systems on English language material or other Western languages, and their clients are often law firms, accountancy firms, etc. And they haven't had the same sort of investment of training their systems on Indian languages as they have with the Western languages. But I think that they definitely should do, and certainly we are making the case with some of the commercial providers that it would be very useful for them to do that, because we already use their software at the British Library and it would help us open up an enormous amount of material. But getting to your question about languages and intermediary languages, well, yes, a lot of these systems, I know that Arabic, for example, is something that is working quite well with a lot of OCR systems. In terms of the Indian scripts, it's unfortunate that Abby doesn't support them yet. Tesseract does, some of the open source systems do, and Transcribers, like I've said, is very good. So that would work with the other Indian languages, not just Bangla. But it does require the manual training first of all. So these systems, they are often set up to work with any Unicode script that has a computerized coded script already for them. So yeah, the answer I think is that yes, it really depends on the language. You have to first of all try it and see how well the OCR systems deal with it, and then you have to look at it and say if the results are not great, then it requires further training of their system, and that in itself requires manual transcription, unfortunately. But it's possible to get very good results, as we've seen with Bangla. If I was to try to OCR the Bangla manuscripts, I would get far worse results right now. But we would need to probably transcribe a few hundred pages. Yes, it's unfortunate that the Indian scripts are not widely supported at the moment.
The one challenge that we face today, India on the brink of digitizing lot of this archival material available, and something when we float a tender for doing this for different Indian languages using the OCR software, most of these vendors shy away, saying, please restrict it to in the English language. That's a huge challenge for us today, because a lot of these libraries, including the National Library, have literature or books on the the local languages, and we have many such languages in India. Thanks a lot, Derrick, for your reply. Thank you so much.
Thank you. I think as well you could consider getting in touch with IIIT Hyderabad, Indian Institute of Technology Hyderabad, because they're doing Professor Jawahar there is doing some good work with OCR of all Indian languages. He's from their computer vision department. So I know that he's interested in this area, and there are some other institutions within India that I'm aware of that have been doing some good work as well. And I believe it's BRAC in Bangladesh, in Dhaka as well, have also developed some tools. So there is a growing community of institutions who are taking it seriously and want good results. But I appreciate as well, it's very frustrating to have your collections and to be able to digitize them, but to meet with this kind of frustrating restriction of not being able to extract the text. But one thing that we would like to do with our project is make available the results and the training material available to you. And if you do have Bangla material and you end up using Transcribers, then please do consider using the trained model that we have created. If you have printed Bangla, it might save you a lot of time and effort, so you wouldn't have to create a lot of manual transcriptions.
Tom, there is a question for you from one of the participants. How OCR can help visually impaired users?
So, well, I certainly know that when it was first developed, the technology, I think I mentioned this, its primary purpose was actually to help the visually impaired, because they created a device that could be scanned across a page of text, and as it read each character, it produced a different tonal sound that the person was able to detect and understand what they were actually reading from that. So another kind of offshoot of this technology is text-to-speech as well, which is where systems can read the text on the page and convert that into audio. So that might be a solution. it's not an area that I've worked within or know an awful lot about, so probably not very qualified to talk about it. But yeah, text-to-speech technology is related to this.
So if you have any other questions, you can please ask.
I see another question, yeah. So other than transcribers, is there any other tool of OCR which is
Yeah, one
equally
more
effective?
question is there.
So is there any other tool that's...
There is one question.
Yes. Well, I can only speak to the experience that I've had and the experiments that I've carried out. So other users and investigators of OCR may have had different results with other tools, but I was, for Indian languages and Bangla, nothing has compared to transcribers for us so far. Tesseract, there are a few that I actually haven't tried yet, which could be good, but I'm not expecting to be as accurate as transcribers. And there is Tesseract, which we've used a little bit. That's not as good as transcribers. And there is something called Kraken. There is another tool, Calamari. These are open source tools that require using the command line a little bit. So they're a little bit more difficult from a user perspective, but I would encourage you to use those if you get a chance to, and it's something that I'd like to try. And if I do, I would share the results with you. But the answer to your question, I think, is no. What are the copyright issues associated with OCR books in Indian languages? I think you have to understand the original copyright restrictions on the books themselves. So if your books are in copyright, then I think the copyright would extend to the OCR as well that you produce, quite possibly. Yeah, again, I don't know a lot about this area because the books that we've been digitizing and OCRing are actually in the public domain. But yeah, I think you would, I'm not sure if you have a team at your library or your institution who looks specifically into copyright, but what we try to do at the beginning of each of our digitization projects is to assess the copyright restrictions and assign kind of access and reuse restrictions on data sets that are produced from our digitization projects. So we have a team that looks after that. But yeah, I think that you'd want to be sure of what are the original copyright restrictions in the material, first of all. Sorry, that's not probably not a conclusive answer.
So if you have any other question, you can ask.
You can ask, and you could also email me afterwards as well. I'm happy to take emails.
I think the idea of sending through email is better. We can close the meeting.
Yes, sir.
And one announcement for all the participants, there is a link I have shared. The link will be active for 1 hour. You just fill it up for your certificate. Okay, later on you don't correspond for certificate.
Thank you, Dr. Pathu. So now we are in the concluding session. I request Mr. Akhlaq Ahmed, the Assistant Library Information Officer, to deliver the vote of thanks.
Thank you, Gajlashmi. On behalf of Director General and on my own behalf, I thank Mr. Tom Derrick, share his rich professional experience and nice webinar on development with optical character recognition for printed Bangla at the British Library. I also thank the staff of National Library and all participants who spared their valuable time and attended the webinar. And a special thank to the convener, our Director General, National Library and Joint Secretary, Ministry of Culture, Sri P.L. Sau sir, and Officer on Special Duty, Sri K.K. Kuchokosi sir, and my colleague Dr. Partho Sathi Das and Srimati E. Gajlashmi to organize the webinar successfully. Thank you. Thank you.
Thank you so much.
All the participants.
Thank you, Tom, once again.
All the participants, the meeting will be active for 1 hour. There is a link. You please get it filled and submit within 1 hour. Okay.
Thank you. Thank you so
Okay,
much.
thank you all.
Thank you so
for
much,
having
sir.
me.
Thank you, sir.
Thank you, Tom. Thank you.
Thank you. Yes, it was a pleasure to speak to you all. Thank you.
Today. Thank you so much. Bye. Take care.
Again, thank you, Tom. We meet a lot of gap after 2 years. Thank you.
Yes, we should talk more often. Yes.